Let's go ahead and start off with this walkthrough of Proxy ARP. And here we've got host A, IP address of 10.2.1.2, and a MAC address of all A's. On our router, we've got on Ethernet 0, 10.2.1.1/16, so it's on the same subnet as host A. And on Ethernet 1, 10.3.1.1/16, and a MAC address of all 2's. Now, host B has an IP of 10.3.1.2/16, MAC address all B's. In case I didn't mention it and you're listening in instead of watching, Ethernet 0 on the router has a MAC of all 1's. Now at this point, and you can see what's going to happen immediately, host A, sends an ARP request for the MAC address of host B. And the router receives the request on its E0 interface, and it's not going to forward it because it's a router. But what it will do when Proxy ARP is running is send a Proxy ARP response back to host A. And that request is going to tell host A that the MAC address of the device at 10.3.1.2 is all 1's, which is actually the MAC address on the router Ethernet 0 interface, which is the interface that received that ARP request. And here's exactly what happens. Proxy ARP response going back from the router. And here's what happens as a result, and why you can get some results that look a little odd. Now, as a result of this, host A, of course, in its cache would put the mapping in there, no problem there. And now when host A sends data to host B, the source IP and MAC addresses, they are that of host A. The destination IP address is that of host B, you would expect that, but the destination MAC address is that of router 1's E0 interface. It's worth going over one more time. You should know what the source and destination IPs are going to be in this scenario. Of course, they're going to be exactly what we would expect. Host A's source IP, host B's destination IP. Then the source MAC, that's going to be host A, of course, but the destination MAC is going to be a little different than we would expect, and it's going to be the all 1's address, the MAC address of Ethernet 0. Now, the router is going to forward that data to host B, and the destination IP and MAC will be that of host B. What changes here is the source MAC address is going to be that of the router's E1 interface, the interface that's actually forwarding the data. So there's what happens as the packet leaves host A and comes into Ethernet 0, and then as it leaves Ethernet 0 and goes to host B, the source MAC address is going to be that of the interface that's doing the forwarding, which is Ethernet 1, and every other address there, the source IP, destination IP, those are unchanged, and the source MAC, we know what that's going to be. Of course, the destination MAC will be the all B's address. And as a result of that, this is exactly what host A's ARP cache is going to look like. It's going to have host B's IP address, but it's going to have Ethernet 0 on the router's MAC address. Notice in this situation and in this scenario, the IP addresses never change. So if you're ever asked anything like this, practice exam, real exam, job interview, whatever, the IP addresses never change, but the MAC addresses will. Now that's enough ARPing around for a while. Let's talk about how these hosts get their own IP address in the first place. And that's with our old friend, the Dynamic Host Configuration Protocol. And I know I mentioned this early, but I want to mention this again. I'm always talking about IP version 4 unless I specifically mention IP version 6. The reason I'm bringing that up is in the IP version 6 section and in the separate course I'll be offering on that in the future, there is another kind of DHCP, and it operates much differently. So again, just want to draw that line. This is version 4. One way or the other, though, a host needs some really important information before it can even start to act as part of the network. What's my IP address? What's my network mask? Where are the DNS servers? What's my default gateway? So we have two options for getting that information to the host, and I've done both. Visit each workstation and configure the information manually, or enable each workstation for DHCP. Now you might think there is no big difference there since each option involves visiting the workstations. Well, that's true. We have to, as we say, touch the machine, once, touch the PC once. The difference, my friends, is in how many times you end up doing that. because sooner or later, no matter how small your network is, no matter what happens, some of this information is going to change. The DNS server location is going to change one day. The default gateway might change one day. You never know, but something's going to change. And here's the problem. If you previously hard-coded the information on all the hosts, guess what you got to do now? You got to go out and visit every workstation and change the information manually. And you're really going to hate it. Because not that it's incredibly difficult, but having had to do that once because DHCP was not in place, and this was quite a while back, but the predecessors before I got there had not been using DHCP, and I was ready to push out one change via DHCP. I'm like, what do you mean you don't have a DHCP server? So it is a long, convoluted process because, like I said, there's the more visitations we do to PCs and the more typing in of manual entries, the larger the chance, the bigger the odds that we're going to make an error or we're going to miss a workstation. If you use DHCP to begin with, though, all you have to do now is change that information on the DHCP server. And you've got some options there as to whether you actually push the information out or, end everybody's lease, or if you are just going to let them wait until their next lease to get the information. I like to be proactive and push it out. But let's talk about the basic operation of DHCP right now, because again, when the choice is between visiting hundreds or thousands of users or even dozens, because we've got other things to do with our time, you don't want to have to go back to even dozens of workstations manually when you don't have to again and again and again. Just use DHCP because it doesn't make you lazy, it makes you smart. Your time is your most valuable resource. Also, let's think about our mobile users. Today's everybody's a mobile user. Well, if you're a laptop owner, there's no way that hard coding IP address information on your laptop or your phone or anything is going to work out, because what happens when you go to a coffee shop? What happens when you're in the airport? What happens when you're at the grocery store and you want to go on the net, check something out? Well, you've always got to authenticate to a network and be given that information. So it's not like the information that you hard code at the coffee shop is going to work at the grocery store. So really today's networks demand dynamic assignment of IP address information, and that's what DHCP is all about. There are 4 basic steps that allow a host, which we're going to call the client, the DHCP client, to get all of this information from a server. And at first, again, never use acronyms in a job interview, but you can easily keep them in mind if you're hitting this for the first time by using the acronym DORA. Discover, offer, request, acknowledgement. But that's not all we need to know about them. We need to know what's going on in each one. So let's start with that. The client is starting the process by sending a DHCP discover message with the destination IP address 255, 255, 255, 255, which is a broadcast. And the client has to send a broadcast since it has no idea where the DHCP server is. It's basically this host yelling, hey, you guys, is anybody out there a DHCP server? I really wanted to do that better, but I'd rip my throat up. So any DHCP server that gets that message is going to respond with an offer. And the offer contains the following. It's going to say, here's the IP address that I'm offering you. Here's the network mask that I'm offering you. And here's how long you can keep it. And this is the lease that I mentioned earlier, because you generally want your users to have to renew their leases. And most networks go with 30 days. I know some that go with 7. But it's not something you want to set for every hour or anything like that. It's kind of ridiculous. Of course, that message, the DHCP offer, needs to include the IP address of the DHCP server that is making the offer in the first place. Now, since that original DHCP discovery, and you can call it discovery or discover. I go back and forth, and I see books use both terms. Really doesn't matter. But that original DHCP discover message sent by the host, it's a broadcast. And if we're lucky, more than one DHCP server might see it and respond with an offer, because we love having a backup plan. If one server goes down, the other one can answer. Well, the choice made by the host in DHCP of which offer to accept is not exactly scientific. It simply accepts the first offer it gets. Doesn't actually get any less scientific than that, I think, but that's what we've got. Now, that DHCP offer, that's also a broadcast. And that's necessary because the client doesn't have an IP address yet, right? So we can't exactly unicast it back. So by sending this message as a broadcast, the client is guaranteed to see it and the other clients will just ignore it. Now, the client then broadcasts a DHCP request, and it's identifying the offer that it's accepting. This is usually a broadcast, not always. It's usually a broadcast, though, and how the DHCP server knows, hey, that guy's accepting my offer, there's a transaction ID value in the request message. If you're really interested in seeing the nuts and bolts of each message and every single field, Wikipedia, it does have an excellent DHCP page. We don't need to go into that kind of detail for the CSUMP, but it's some good additional reading. Because under certain circumstances, such as the client renewing a previous lease, this can be a unicast. So I've seen it described both ways. Again, I would not worry about it for the exam, but know that it is usually a broadcast. Finally, that DHCP server whose offer was accepted sends an acknowledgement back to the client with any other information that the client needs. And the client is not officially using that IP address yet, so this message is also a broadcast. Now, the process is now complete and the client's all set. And of course, what are we going to do about that? We're going to verify it, because when you're troubleshooting, you get a call to a station, so hey, I can't get on the network, I can't do anything, etc. After you check the physical layer and just make sure the PC is on, you'd be surprised how many end users miss that. We have to check that. But if all the cabling's fine, you got a link light in the back with a network card, everything's looking good, running ipconfig all is a great troubleshooting step, because you can see immediately if there's any kind of trouble with DHCP, because you can verify that they're running it with that as well. So let's bring that up actually. That's the router. Let's bring up a host instead. Again, a lot of information you're going to see about a lot of different interfaces that's on here, but you can see here's the deal with the DHCP server. At least it knows where that is, so all is well. It's got an IP address, all that great stuff, so everything's fine there. And you'll also notice it's mentioning something about DHCP v6 here. That is DHCP 4 IP version 6. But right now we're sticking with 4, so you can see this one's all fine and dandy. Knows where the server is, it knows where the default gateway is. You can see when the lease was obtained and when it expires, so there's some good information in there as well. And also the IP version 4 address right here in the middle, along with its subnet mask. So a lot of good information there in ipconfig/all. In the next video, we're going to get some routers involved, because as you can see on the screen right now, this process is nice and clean as long as we have a DHCP server on every physical subnet in our network. But once we get routers involved, things get just a little bit trickier, and that's what we're going to see on the very next video. Oh, excuse me, there we go. We're going to see what happens when we start getting some routers involved in this process and what we need to be aware of, and we will take care of that on the very next video. See you there.